हाँ सर, ओके, रिकॉर्डिंग ओके सर, वो है चालू।
So there are two types of MOSFET. The one MOS is known as NMOS and second one is PMOS. This channel is known as drain, source and gate. So we are having three channels in the system. So what I can say, the mode of operation for this, first mode is when VGS is less than VTH, then value of IDS is equivalent to 0. And this mode is known as cutoff mode. The second mode is when VGS is greater than or equal to VTH, and VDS is less than VGS minus VTH, then this mode of operation is known as triode region. The value of current IDS will be mu n into COX into W by L into VGS minus of VTH whole is into VDS minus VDS square divided by 2, and this mode of operation is known as triode region. इसका क्या नाम है? एक बात हमने कल कर ली थी for NMOS transistor. So just to remind the formulas and saying, I'm writing it again. This is what NMOS. Next is the third one is VGS is greater than VTH and VDS is greater than or equal to VGS minus of VTH. This flat region is known as saturation region, है ना? ध्यान रखें, MOSFET works as an amplifier in saturation region. So this is the idea. And what will be the value of current? You can say the value of IDS is equivalent to, just replace VDS equal to VGS minus VTS. So this is 1 by 2 mu n into COX into W by L into VGS minus VTH whole square. So we are having three modes of operation for the MOSFET, you know, and what I can say, you will have this also, but let's make it gate, drain and source. So these are the three terminals. Next we are having one more design which is known as PMOS. तो PMOS के भी VI characteristics लिख लेते हैं हम. This is gate terminal. This is source terminal. And this is drain terminal. So what I can say, when VGS is greater than VTH है ना, द वैल्यू ऑफ ड्रेन करंट विल बी 0। हम करंट के सारे एक्सप्रेशन को सेम रखेंगे, जैसे पॉजिटिव वैल्यू ऑफ VGS क्रिएट्स चैनल इन NMOS, वैसे ही मुझे क्या बोलना पड़ेगा, द नेगेटिव वैल्यू ऑफ VGS will create channel for PMOS, है ना, this is the idea. So what I can say, when VGS is less than VTH and ID and, है ना, मैं केवल कंडीशन चेंज कर रहा हूं, तो एक्सप्रेशन फॉर द करंट विल बी सेम, या इसको उल्टा कर ले आप, दोनों तरीके से आंसर आ जाएंगे, इट विल नॉट अफेक्ट योर एनालिसिस। सो यू कैन से VDS is greater than VGS minus VTH, है ना, और VTH थ्रेशोल्ड भी कैसा होगा इस बार, द थ्रेशोल्ड विल बी नेगेटिव थ्रेशोल्ड। सो हाउ इट विल वर्क, यू कैन से ID is equivalent to mu P into COX into W by L, where COX is oxide capacitance and mu P is the mobility, and this is multiplied by VGS minus of VTH. The current expression is same whether it's N type और P type MOSFET, but इस बात का ध्यान रखिए सारे साइन के साथ यूज करना है ना, पॉजिटिव है तो पॉजिटिव, नेगेटिव है तो नेगेटिव, साइन को अवॉइड नहीं करना है। So this is the value of current, and this region is known as triode region. And this next region is what I can say is known as saturation region, where VGS is less than VTH and VDS is less than or equal to VGS minus of VTH, है ना, VTH को VTHP लिख दो, है ना, VTH in this case is VTHP. This is the idea. So what I can say, the value of current ID will be 1 by 2 mu P into COX W by L. This is very important design parameter, the width by length ratio, है ना, this is important factor in transistor scaling. VGSP minus VTHP whole square. So this is the value of this is हम एग्जाम्पल लेते हैं कुछ और लेट्स ट्राई दिस प्रॉब्लम्स. Let's take example to understand NMOS and PMOS. Example number 1. And what this example is saying, I have a 2.5 volt source. So this is .5 volt. This is RD. Then we are having okay. Minus 2.5 volt. Then we are having one gate terminal which is connected to 0. What else is given? The parameters are given that ID for this circuit, the drain current for the circuit is equivalent to 0.4 milliampere. इस सर्किट का जो ड्रेन करंट होगा वो 0.4 milliampere. और क्या बोला है? That this voltage VD, if this voltage is represented by VD, the VD of the circuit is equivalent to 0.5 volt. ठीक है. और क्या दिया है? VT, the threshold voltage is given as 0.7 volt. और क्या दिया है? The product of this mu n into COX is given as 100 microampere per volt square. This is also given. L is equivalent to 1 micrometer and W equal to 32 micrometer. This is given, and we are interested in the value of RD and RS. Find the value of RD and RS. So let's check in which region this transistor is working. Can I say the VD for the circuit is given by 0.4 volt, 0.5 volt, sorry. तो VD का वैल्यू सर्किट में कितना दिया है? These all questions are not previous year. This value is given as 0.5 volt. So can I say the only possible direction of current inside the circuit is this? This is the possible direction of current. So I can say the value of IDS or ID, drain current, is equivalent to higher potential is 2.5 volt, the lower potential is 0.5 volt, and divided by RD. So I can say RD is equivalent to 2 divided by IDS, and IDS is given as 0.4 milliampere. So you can say the value of RD, the value of drain is equivalent to 5 किलो ओम. तो हमने एक रेजिस्टेंस का वैल्यू तो निकाल लिया कि this resistance is having value of 5 kilo ohm. Now we are interested in this voltage Vs. What will be the value of Vs? So can I say I have to apply the concept of the idea of drain to source current. So I can say the drain to source current IDS है ना. मैंने मान लिया कि लेट जैसा बीजेटी में अज्यूम करते थे यहाँ भी ऐसा अज्यूम कर लिया. लेट transistor is working, our transistor is working, our MOSFET is working, in saturation region. Our MOSFET is working in saturation region. Our MOSFET is working in saturation region. So this is our idea of analyze the transistor. So what is saturation region? We have two conditions that VG for NMOS, VGS should be greater than VTH and VDS should be greater than or equal to VGS minus VTH. जैसा आप ट्रांजिस्टर बीजेटी में करते थे कि बाय अज्यूमिंग द फॉरवर्ड एक्टिव रीजन आप सारे कैलकुलेशन करते थे, देन यू विल स्विच टू द फिर कंडीशन आप चेक करते थे, वैसा यहाँ भी हम करने वाले हैं. तो मैं क्या बोल सकता हूँ कि इन आवर सर्किट IDS is equivalent to IDS is equivalent to 1/2 mu n into COX into W by L into VGS minus VTH whole square. So I can say IDS, and what is value of IDS? I can say the value of IDS is equivalent to 0.4 milliampere. Then this is equivalent to 1/2, and the value of mu n into COX is given by 100. ये वैल्यू कितना दिया है? You can say this value is 100 microampere per volt square. So this is 100 units का ध्यान रखें आप, microampere per volt square. W by L ratio is given as 32. पुराना हो गया पर ठीक है. VG, the value of VG is what? 0. है ना? VGS कितना होगा? You can say the VGS is equivalent to VG minus VS. तो VG का वैल्यू है 0 एंड माइनस टाइम्स ऑफ VS minus 0.7 whole square. So this is our calculation for calculating the VS. कि what should be the value of VS in the circuit. तो सर VS का वैल्यू कितना होना चाहिए जो आपको यहाँ दिया है. Now I can calculate. I can say this is 0.4 milliampere into 2 divided by what I can say divided by this divided by 100 into 10 raised to the power minus 6 divided by 32 equal to Vs plus 0.7. और इसका क्या आ जाएगा? You can take under root of this and this can be plus minus. So these are two possibilities. Okay, so can I say मिली से ये कैंसिल हुआ और ऊपर आ जाएगा 10 रेज़ टू द पावर 3. तो इसका 0 हटा दो और यहाँ हो जाएगा 200. तो ये हो जाएगा 200 200 से ये 200 कैंसिल. ये हो जाएगा 1/8 नहीं 8/32 1/4 यानी प्लस माइनस ऑफ 1/2. सो आई कैन से दिस आंसर इज 1/. This is 8/32. 8/32 is 1/4. 1/4 is equivalent to Vs plus 0.7, and this can be written as plus minus 0.5 equal to Vs plus 0.7. So either you can take Vs equal to 0.5 minus 0.7, or you can take which is minus 0.2 volt, or Vs is minus of 1.2 volt. Now I am interested in VGS minus VT. है ना, दो वैल्यू आई है मेरे पास. There are two option available for Vs. So what should be the condition? The condition should be VGS should be greater than VTH. So let's select option number 1. Option number 1. What option number 1 says? VG कितने वोल्ट पे है? 0. माइनस VS कितना हो जाएगा? माइनस ऑफ 0.2 should be greater than 0.7. क्या ये करेक्ट है? ये तो नहीं है. तो फर्स्ट ऑप्शन तो ट्रांजिस्टर को कहाँ ले जा रहा है? पहला जो ऑप्शन है this brings transistor into the saturation cutoff region, है ना? So this is not correct value, because for Vs equal to minus 0.2, transistor operates in cutoff. Okay. Now the next answer is Vg again. Let's take Vg equal to 0.7. Sorry, minus 1.2. So Vg is 0 minus 1.2 should be greater than 0.7. Channel formation की यही condition है ना? So VGS is greater than VTH. And if VGS is greater than VTH, so you can say VS is equivalent to, जो वैल्यू आया है VS का कितना आया है, minus 1.2 वोल्ट. अभी भी प्रॉब्लम सॉल्व नहीं हुआ है ना. So let's say this value is minus 1.2 वोल्ट. Now I can have करंट, तो इसी डायरेक्शन में मिलेगा आपको. तो करंट का वैल्यू क्या हो जाएगा? द वैल्यू ऑफ करंट इज हायर पोटेंशियल माइनस लोअर पोटेंशियल. सो यू कैन से द वैल्यू ऑफ करंट ID is equivalent to minus 1.2 plus 2.5 divided by RS, where ID is given as 0.4 milliampere. So what I can say, the value of RS for the circuit is equivalent to 1.3 divided by 0.4 milliampere. 0.4 milliampere ऊपर जाके बना लेगा किलो ओम, और 1.3 divided by 0.4 will be 3.25. So what are the answer for this question? RS का वैल्यू आया 3.25 किलो, and RD का वैल्यू कितना आया था? The value of RD is equivalent to 5 kilo. So this is our discussion of question, how we can approach the question. So this is the idea to approach the question. One more thing, you can check here, all conditions are satisfied or not. So let's start. What I can say, है ना, how to check conditions, कि हमने जो condition लिया था, हमने condition क्या लिया था कि our transistor is working in saturation region, है ना. Condition for condition C that our transistor is working in saturation region, क्या वो correct था कि नहीं था? Transistor is working in saturation. Transistor is working in saturation. क्या ये ठीक है या नहीं है, ना? So this is our main concern. कि what about this? Is this correct or not correct? So what I should say? In transistor, we have all, this is our gate terminal, this is 2.5 volt, and this resistance is RD. This is minus 2.5 volt. This is RS, and this value come out to be 3.25 K, and RD का value हमने निकाला कितना 5 K. What are the remaining voltages? The voltage at this point is already given 0.4 volt, and voltage at this point is given as minus 1.2 volt, which is Vs, and the voltage here Vg is given as 0. So I can find the condition. What my and Vth, the threshold voltage of this device, is given as 0.7 volt. ये इसका threshold है. So what I can say that for saturation क्या condition थी? Vgs must be greater than Vth. तो VGS देखें, VGS कितना आया है? VG minus VS should be greater than or equal to VTH. What is the value of VG? VG is 0, minus VTH is minus 1.2 volt. This should be greater than or equal to VTH, which is 0.7 volt. तो ये correct है? Yes. ये किसकी condition है? चैनल फॉर्मेशन का कंडीशन है, चैनल फॉर्म करने का कंडीशन है. नाउ वी आर इंटरेस्टेड इन द कंडीशन ऑफ सैचुरेशन, एंड व्हाट दैट कंडीशन इज VDS शुड बी ग्रेटर देन और इक्वल टू VGS माइनस VTH. चलो VDS निकालते हैं. VD कितना है? ये ड्रेन टर्मिनल है, तो ड्रेन टर्मिनल में यहाँ का वोल्टेज नहीं, इस टर्मिनल का वोल्टेज. VD इज इक्वल टू 0.4 माइनस VS कितना आ जाएगा? 1.2. माइनस किया तो प्लस. दिस शुड बी ग्रेटर देन और इक्वल टू VGS. VGS इज इक्वल टू व्हाट? VGS इज 1.2 वोल्ट. minus 0.7. So what I can say, 1.6 volt is always greater than 0.5 volt. तो दोनों कंडीशन को ये सेटिस्फाई करता है. दैट्स वाई जो हमने अजम्पशन लिया था, वो अजम्पशन कैसा था? करेक्ट. दिस अजम्पशन that our transistor is working in flat region or saturation region is correct. This assumption is correct. So this is how we can analyze one transistor. Let's take one more example and let's understand this, how this will work. The question is, let's move to the example number 2. Okay. So what is our question? We are having this. We are having one NMOS transistor. We are having one NMOS transistor, and transistor looks like this. Okay. And this question, what they are saying that ID, the drain current is 80 microampere. A very small drain current is in the circuit. You have to find the value of R. So we are interested in the value of R. What is the value of R? And voltage VD, है ना? VD ड्रेन वोल्टेज का वैल्यू भी निकालना है. ये दो वैल्यू में हम इंटरेस्टेड हैं. और क्या दिया है? VTH for the circuit, the threshold voltage of the circuit is given as 0.6 volt. इसका जो threshold voltage होगा वो कितना दिया है? 0.6 volt. And mu n into COX for the circuit is given as 200 microampere per volt square. And what else is given? L is equivalent to 0.8 micrometer. And width is given as 4 micrometer. And okay, so this is our question. And let's see how we can analyze this circuit. Again, to start analysis of this circuit, अच्छा एक बार और ध्यान रखें, whenever what is condition for saturation, है ना? I can say condition for saturation. So क्या क्या condition है for saturation? You can say this need to perform two condition. अगर कोई ट्रांजिस्टर ये दो कंडीशन को सेटिस्फाई करता है तो you can say your transistor is correct. And what is first condition? That VGS should be greater than VTH. And what is next condition? VDS should be greater than or equal to VGS minus VTH. So VGS, VG is what? VG is VG. तो अगर ट्रांजिस्टर में चैनल बन गया है, VTH का वैल्यू 0.7 वोल्ट है, तो VDS, let's write what is VDS. You can say VDS is VD only. या मैं ऐसा बोल दूं, for this transistor VG is equivalent to VD is equivalent to VG. So I can say VD is equivalent to VG. We can say VD is equivalent to VG. तो इसको मैं लिख देता हूं VG minus VS तो 0 है, should be greater than equal to VG which is also VD minus VTH. अब ये बोल रहा है कि 0 should be greater than or equal to minus 0.7 और ये हमेशा ट्रू होगा. तो आप ध्यान रखो कि जब भी आपके पास ड्रेन एंड व्हाट इज आवर कंक्लूजन, whenever drain and gate are connected, what we can say, whenever drain and gate are connected, and if transistor satisfies this condition and transistor satisfies the condition VGS greater than or equal to VTH, then ट्रांजिस्टर इज ओनली वर्किंग इन सेचुरेशन रीजन. इसका मतलब क्या हुआ कि ट्रांजिस्टर कहाँ वर्क कर रहा है? केवल सेचुरेशन में ही हो सकता है और किसी रीजन में नहीं हो सकता. एंड दिस इज करेक्ट, दिस इज ऑलवेज करेक्ट, है ना. ये हमेशा क्या होगा? ये हमेशा ही सही होगा, ये गलत नहीं हो सकता. तो इस बात का ध्यान रखें. दिस इज वेरी इंपॉर्टेंट पॉइंट विच वी वांट टू रेज. नाउ व्हाट आई कैन से, आई कैन हैव द आंसर फॉर करंट. So current is equivalent to saturation का जो करंट होगा 1/2 mu n into COX into W/L into VGS minus of VTH whole square. चलो डेटा ले लेते हैं. What are the data? ID equal to 80 milliampere. Okay, ID is equivalent to 80 microampere is equivalent to 1/2. ये दिया है 200 microampere per volt square into, we are interested in W/L. So W/L ratio is 0.4 divided by 0.8. So this ratio comes out to be 4 microampere divided by 8 है ना. 4 divided by 0.8 is the aspect ratio of this circuit. Now we are interested in VGS. VG is VG minus VS is connected to 0 minus VTH is given as VTH का जो वैल्यू दिया है that value is given as 0.6 I think. Okay. Okay, this is the idea. So we can find the value of VGA. So I can say the value of VG minus 0.6 whole square is equivalent to micro and micro cancel. So this is 160. This 2 is multiplied into 200 and this is 5 za. So this value comes out to be 160 divided by 1000. तो इसका वैल्यू आया अंडर रूट 1000 for 16 का 4 और इसका आया 10. So what I can say that VG minus 0.6 whole square come out to be plus minus 0.4, not whole square, it's a power 1. So you can say VG is equivalent to plus 0.4 plus 0.6 and second possibility is VG equal to 0.4 minus 0.4 plus 0.6. So VG इक्वल टू 1 वोल्ट और यहां से आया VG का वैल्यू कितना 0.2 वोल्ट. इनमें से कोई एक कंडीशन ऐसी होगी जो ट्रांजिस्टर को ऑन ही नहीं होने देगी है ना. ऑन होके तो डायरेक्ट कौन से रीजन में जाएगा, सेचुरेशन. तो व्हाट इज योर कंडीशन फॉर फॉर्मेशन ऑफ चैनल, दैट VGS शुड बी ग्रेटर देन और इक्वल टू VTH. VG का वैल्यू आया 1 माइनस VS का वैल्यू 0 इज ग्रेटर देन 0.6. ये तो करेक्ट है, इसमें कोई परेशानी नहीं है. VGS is 1 should be greater than 0.2. ये करेक्ट है क्या, ये करेक्ट नहीं है. सो दिस इज इनवैलिड वैल्यू. ये कैन आई से द VG इक्वल टू, कैन आई से द वैल्यू ऑफ VG इक्वल टू 0.2 इज विल ब्रिंग योर ट्रांजिस्टर इनटू द कट ऑफ. ये ट्रांजिस्टर को कहां ले जाएगा, कट ऑफ में ले जाएगा. सो दिस इज यूजलेस पॉइंट. So what I can say, the value of VG is equivalent to 1 volt. मेरे पास VG का वैल्यू कितना आया, VG लिख दूं उसको या मैं इसको लिख दूं VD. दिस ऑल वैल्यूज इज इक्वलेंट टू 1 वोल्ट. ये सारी वैल्यू किसके इक्वल आई है, 1 वोल्ट के इक्वल आई है. दिस ऑल वैल्यूज आर इक्वलेंट टू 1 वोल्ट. नाउ if this value is 1 volt, what I can say, if this value is 1 volt, I can find the value of R, that ID is equivalent to higher potential which is 3 volt minus lower potential 1 volt divided by R. और ID का वैल्यू कितना है, the value of ID is equivalent to 80 microampere is equivalent to 2 divided by R. So R equal to 2 into 10 raised to the power 3 into 10 raised to the power 3 divided by 80. So you can say this is 1 by 40. ये कैंसल हुआ तो ये हो गया 100 by 4 which is 25 kilo ohm. So what I can say, the value of R is 25 kilo ohm and we can comment on this transistor. यहाँ से हमने क्या सीखा कि जब भी अगर आपके पास ड्रेन और गेट टर्मिनल कनेक्टेड हो तो आपको केवल क्या देखना है कि if only if VGS is greater than VTH, अगर चैनल ऑन है तो ये ट्रांजिस्टर केवल कौन से रीजन में काम करेगा? दिस ट्रांजिस्टर विल ओनली वर्क इन द saturation region. This transistor will only work in saturation region. So this is the idea for the circuit. ये सर्किट का टोटल आइडिया होगा. Let's take a few more problem based on same concept. नया प्रॉब्लम लेते हैं एक और. Okay, we have one more question and the question is given like this. Okay, this is one. NMOS is given. We are taking question on NMOS, then we will start with the PMOS. है ना? So both analysis are same. कोई अलग नहीं है उनमें. है ना? This is PMOS. Sorry, this is NMOS. NMOS circuit. क्या क्या दिया है इसके लिए? Let VT is equivalent to 1 VTH 1 volt. Well, what else is given? That Kn dash into W by L. What is Kn dash? It is mu n into COX. This value है ना, Kn dash is given by process conductance parameter, which is mu n into COX. वो direct दे दिया है कितना? Into W by L. It is given as 1 milliampere per volt square. ठीक है? और क्या दिया है? Okay, fine. All resistances are given, so I can say this resistance is equivalent to 6 kilo ohm. This resistance RS is equivalent to 6 kilo ohm. Okay, so what else is given? Okay, nothing is given now. And we are interested in all voltages, calculate all voltages and currents. So idea is calculate all voltages and currents. है ना? तो चलो करते हैं start. What first thing I can say about this circuit, that the value of Ig, I can tell you more than one approach to address this question. You can say Ig is equivalent to 0. क्या Ig का वैल्यू कितना होगा? Ig is equivalent to 0. So I can say there is only one current. And that current, let's say this current is I. So I can say the value of current I is 10 volt divided by 20 mega ohm, है ना? And what will be the potential drop here? The potential drop here is, वैसे भी वोल्टेज डिवाइड हो गया, 10 वोल्ट लगाया था दो सेम रेजिस्टेंस से, 5 दोनों में चले जाएगा. सो व्हाट आई कैन से, द VG is 10 divided by 20 into 10, which is equivalent to 5 वोल्ट. तो अब मेरे पास यहाँ का वैल्यू आया है कितना, VG का वैल्यू आ गया है 5 वोल्ट, है ना? सो VG इज इक्वलेंट टू 5 वोल्ट. Now, VG is available to us. Can I say the current here, this potential is, current यहाँ कितना flow होगा? This current will be IDS or ID. This current will be ID. और ये करंट भी कितना होगा? This current is also equivalent to ID. So I can say the potential at source terminal will be 6 times of ID, where ID is in milliampere, so milli ने किलो को कैंसिल कर दिया है ना, ये कहानी है. And this potential will be 10, और यहाँ का पोटेंशियल हो जाएगा 6 ID, तो ये हो जाएगा -6 times of ID. So what we can say, we are having one gate terminal potential which is 5 volt and one drain terminal potential which is 10 minus 6 into IDS, and we are having one source terminal potential which is 6 into IDS बोले ID बोले, एक ही करंट फ्लो हो रहा है. Now I can have the value of current. Let's say our transistor is working in saturation region, है ना? Assumption हमेशा यही रहेगा. Let's say transistor is working in saturation region. Transistor is working in saturation. क्या मान लिया मैंने कि हमारा ट्रांजिस्टर वर्क कर रहा है सैचुरेशन रीजन में. So what we can say कि ट्रांजिस्टर अगर सैचुरेशन रीजन में वर्क कर रहा है तो मैं क्या बोल सकता हूं कि IDS is equivalent to 1 by 2 mu n into COX into W by L into VGS minus VTH whole square. Now, what we know that IDS is not known parameter. IDS हमें पता नहीं कि what is the value of IDS for the circuit. So I can say IDS is equivalent to 1 by 2 mu n into COX is equivalent to this value is given as 1 milliampere. So I can take this as a 1. ID भी मिली में है तो मिली cancel and W by L ratio. Okay, this includes W by L ratio, so there is no need of writing W by L separately. Then we are having VG. What is VG? VG is having value 5 minus VS. What is value of VS? 6 times of IDS minus VTH, which is minus 1 volt, and square of this. Yeah, you are having now a quadratic equation to solve. So what I can say in this quadratic equation, I can say 2 times of IDS is equivalent to 4 minus 6 IDS or we can say 2 times of IDS is equivalent to 16 plus 36 IDS whole square minus 2AB means 48 times of IDS बोले ID बोले मैं एक ही लिख रहा हूँ उनको है ना और we can say this is 36 IDS square minus 48 minus 2 is minus of 50 IDS plus 16 equal to 0. This quadratic equation is the equation for now I can solve this. The value of current come out to be the value is quadratic equation को solve करता हूँ तो what I can say the value of ID as come out to be 0.89 milliampere and IDS equal to 0.5 milliampere. So these are two choices for IDS. ये दो IDS की choices है कि the value can be 0.8 सो दिस आर टू इम्पोर्टेंट रिजल्ट. लेकिन अब इन दोनों रिजल्ट में से कौन सा करेक्ट है तो हमें चेक करना पड़ेगा. व्हाट आई शुड से कि व्हाट आर द वैल्यूज. Okay. So there are two values available, and now I can analyze that Vg is given as जो पैरामीटर डिसाइड करते हैं कि ट्रांजिस्टर किस रीजन में काम करता है उनको लिख लेता हूं. सो Vg is equivalent to 1 volt. Then what else I can say? Vs is 6 times of IDS and Vd is 10 minus 6 IDS. What else we know? That Vth is equivalent to 1 volt. ये हमारे पास this is the complete data which is available to us, and this data is dependent on IDS. So let's take IDS equal to 0.9 milliampere है ना. 0.89 को मैं 0.9 कर देता हूँ. So I say let's say IDS equal to 0.9 milliampere. चलो क्या क्या होता है देखते हैं. जैसे मैंने IDS का वैल्यू 0.9 milliampere किया, what I can say, Vg is equivalent to 1 volt. Vg 1 volt है. Vs कितना हो जाएगा? The value of Vs is 0.96 and Vd is equivalent to not 0.54, it is 5.4. Let me correct it. This is 5.4 volt. And Vd is equivalent to 10 minus 6 into IDS, which is 5.4, and 5, and this is 4.6. So this is the idea for the question. Now we can say the condition VGS should be greater than VTH. VGS का वैल्यू किससे होना चाहिए? VTH से बड़ा होना चाहिए. चलो VG देखते हैं. VG is what? 5 volt. VS is what? VG. VS is what? 5.4 volt. This should be greater than VTH. VTH कितना है? 1 volt. ये करेक्ट है क्या? ये तो करेक्ट नहीं है. तो भाई ये तो मामला नहीं बन सकता क्योंकि ट्रांजिस्टर को can I comment that IDS equal to 0.89 brings transistor in, है ना. This is impossible result कि जब चैनल ही फॉर्म नहीं हो रहा है तो ये 0.89 मिली एम्पियर भी कैसे आ सकता है? Possible because no channel. ठीक है. So this much of current cannot flow through the transistor. Now let's select IDS equal to, let's select IDS equal to 0.5 volt. So I am taking IDS is equivalent to 0.5 milliampere. IDS का वैल्यू लिया सपोज मैंने 0.5 milliampere. So what I can say, VG is 5 volt. There is no change in VG. क्योंकि ये तो आया ही वोल्टेज डिवीजन से था. Then VS is equivalent to 0.6 into 0.5 is 3 volt. VD is equivalent to 10 minus 3 is 7 volt. And VTH is equivalent to 1 volt. So these all conditions are given. So what is first condition? You can say VGS should be greater than or equal to VTH. So VG is what? 5 volt minus VS is 3 volt should be greater than VTH. क्या ये condition ठीक है? Yes, VGS is greater than VTH. This condition is okay. इस कंडीशन में तो कोई प्रॉब्लम ही नहीं है, और इस कंडीशन में अगर कोई प्रॉब्लम नहीं है तो what else I can say that VDS should be greater than or equal to VGS minus of VTH. So we can say VDS, VD is what? VD is, for our discussion, VD is 7 volt. So 7 volt minus 3 volt should be greater than VG 5 volt minus VS 3 volt minus VGS minus VT. So this is 4 volt should be greater than or equal to 4 minus 3, 2, 2 minus 1, 1. ये भी correct है? Correct है. This means our transistor is working in saturation region. Transistor is working for IDS equal to 0.5 milliampere. So this is the idea for the circuit. ये circuit का idea कि how this circuit will work. तो ये उसका working है. Now let's take one more question and let's start this question. What they are saying. Let's take one question on PMOS. एक क्वेश्चन हम लेते हैं किस पे? Let's take one question on PMOS. Question on PMOS. PMOS क्या बोला है? If ID for the circuit is, the drain current for the circuit is 0.5 milliampere. सर्किट का ड्रेन करंट कितना है? 0.5 मिलीएम्पियर. और क्या दिया है? VD for the circuit is equivalent to 3 volt. बहुत अच्छे. और क्या दिया है? Let VTHP is equivalent to -1 volt. क्योंकि अगर PMOS है तो थ्रेशोल्ड कैसा होगा? नेगेटिव होगा. What else is given? Kp prime into W by L, process conductance parameter into aspect ratio, product is 1 milliampere per volt square. This is also given. तो आपको बताना है the largest value of RD that can the largest value of RD can have while maintaining the saturation. The largest value, है ना, मैं सर्किट भी बना देता हूँ. So what is given? Okay, so this is the circuit. The circuit is given. This is 5 volt. We are having two resistors. The resistances are 2 mega ohm and 3 mega ohm. Then we are having this. Then we are having drain source terminal. Then we are having drain terminal, which is RD. And this is connected to ground. This is RD. And what else I can say? I can say that VD is equivalent to plus 3 volt. VD का वैल्यू कितना दिया है? The value of VD is equivalent to 3 volt. This is given in the circuit. So what they are saying, the maximum value of largest value of RD. RD का maximum value क्या हो सकता है? And current is also given 0.5 milliampere to 6 नहीं है ना, और उससे ज्यादा क्या हो सकता है? तो what is the criteria for this? What I can say, a transistor can operate in PMOS can operate. What is PMOS operation? PMOS in saturation PMOS in saturation is given by VGS should be less than VTH, first condition, and second condition, VDS should be less than or equal to VGS minus VTH. है ना? This is the condition for PMOS saturation. तो PMOS saturation का तो कुछ ऐसा condition है. If this is the condition for PMOS saturation, what I can say? So this transistor is what? This is a PMOS transistor. कौन सा है ये? This is PMOS. So VG, can I say this is 5 volt? So current will be 1 microampere. तो यहाँ का जो voltage होगा, that voltage will be 3 volt. है ना? So what is the condition? VG minus 3 volt should be, VG is 3, okay. VG is 3 volt minus VS is 3 volt. This should be less than VTH. Okay, no, this is 5 volt. VS is 5 volt, है ना? नीचे वाला VS नहीं है. So I should say this value is 5 volt. And of course this condition is true. Minus 2 is less than minus 1, है ना? Minus 2 में 1 add करेंगे तो minus 1 पे पहुंचेंगे. So this is fine. Okay, so this is the idea. Can I say what about second condition? You are saying that VDS should be less than VGS. VGS is what? VG minus VS. VG is 3, VS is 5, minus 2. Minus 3, minus 2, minus 3. You can say this is minus 5. And VTH is minus 1. So you can say VDS should be less than or equal to minus 8. This is 3. 3 minus 5 is minus 2. Minus 2 plus 1 is minus 1. Now, what is VD? VD is 0.5 times of RD minus 0.5 should be less than -1. So RD should be 0.5 RD should be less than or equal to 4. So RD should be, हमने क्या किया, डायरेक्ट वही कंडीशन निकाल ली कि जिससे so that our transistor can stay in the saturation. और transistor will stay in the saturation only if the RD is less than 8 किलो ओम. कि RD का वैल्यू अगर 8 किलो ओम से कम हुआ तो ट्रांजिस्टर विल स्टे इन द सैचुरेशन रीजन. दिस इज द फंडामेंटल आइडिया. और कैसे सोचा जा सकता है कि भाई सैचुरेशन के लिए वी नो दैट VTH इज इक्वल टू VGS का वैल्यू कितना आया है. वी नो दैट VGS इज इक्वल टू -1. VGS VG minus VS is equivalent to so RD equal to 8 kilo ohm is the condition for which RD equal to 8 kilo ohm is the condition for which the transistor is working in the forward active region. या मैं ऐसा बोल सकता हूँ कि VD का maximum value कहाँ तक जा सकता है. देखो जरा, you can check the condition also. What is condition? कि let's say इसका वैल्यू अगर मैं ले लूं कितना है ना, let's say ये 0.5 है ना, तो 0.53 आ रहा है तो मैं इसको ले लेता हूँ let's say 4. 8 लिया है तो 8 इंटू 4. कब भी तो ट्रांजिस्टर सैचुरेशन में है. देखें जरा, VDS should be less than or equal to VGS minus of VTH. VD कितना है, VD is equivalent to 4 volt. VS कितना है, VS is equivalent to 5 volt. This should be less than VGS कितना है, -2. VG is 3, VS is VDS, VDS. Okay, this be minus और ये कितना है +1. तो -1 is greater than or equal to -1, ये कंडीशन ट्रू है. अब इसका ये वैल्यू अगर और बढ़ाऊंगा मैं, 4 से और इंक्रीज कर दिया जाए तब गड़बड़ होगा. यहाँ तक तो कोई गड़बड़ क्रिएट नहीं होता. सो यू कैन से कि VD का जो मैक्सिमम वैल्यू हो सकता है फॉर दिस सर्किट, द मैक्सिमम वैल्यू ऑफ VD कैन बी रिटन एज 4 वोल्ट. ये 4 वोल्ट तक जाएगा. तब तक मैं क्या बोल सकता हूँ, दैट अवर ट्रांजिस्टर विल स्टे इन which region? Our transistor will stay in the forward active region, or you can say saturation region. What is meaning of forward active region? We are talking about this is equivalent to forward active region. कि कैसे काम करता है ये? You can say this is our this is, let's say, VDS, and let's say this is IDS. This is output characteristics of MOSFET. Characteristics of the MOSFET. और क्या बोलती है ये characteristics? That initially there is a point so what I can say, and this point is known as VDS saturation. Is equivalent to VGS minus VTH. So initially the output current is a function of VDS, है ना? In this region what I can say is let's say region number 1, and what I am trying to convey is that in region number 1 हमने देखा है that in region number 1 IDS is a function of VDS. This is we are talking before the saturation, and after saturation what I can say? After saturation I can say that current will be the constant current. ये जो current हो जाएगा वो कौन सा हो जाएगा? This current will be constant. And this is region number 2. This region is known as saturation region, है ना? इस region को क्या बोलेंगे हम? Saturation region. And this region is known as triode. This region is known as triode region. So this is the idea. This is the idea how we can approach the characteristics. दो रीजन में काम करता है. Let's say we have one more reason, VGS is less than VTH, and that makes zero current, so no sense. So ये ट्रांजिस्टर can work in these two region, और दोनों रीजन की हमको कंडीशन पता है कि भाई जब when your transistor enters into the saturation region, then VGS your drain to source current is independent to VGS. VDS से independent हो जाएगा. This is only dependent on VGS minus of VT, है ना? In this region this is only function of VGS minus VT. केवल इसी का function होगा. So in next lecture, what I can say, in next lecture we will talk about a CMOS circuit, a very important circuits class of circuit known as CMOS. Very important class of circuit, complementary MOS के बारे में बात करेंगे. CMOS के बारे में बात की जाएगी और देखेंगे how CMOS will work, how this complementary MOSFET structure will work, and we'll talk about the small signal analysis, model for we will start with the small signal model for the MOSFET, and very important aspect which is known as cascade amplifier. We will talk about cascading. We will talk about cascade amplifiers, how you can increase the output resistance when you use the current source in cascade circuit. And one more thing we want is MOSFET current mirror के बारे में भी बात करेंगे. We will talk about MOS current mirrors. MOSFET current mirrors. So we will talk about MOS current mirrors. So this is our topic of the टॉपिक फॉर डिस्कशन फॉर टुमारो, कल इनके बारे में बात की जाएगी, और कुछ गुड क्वालिटी क्वेश्चंस, प्रैक्टिस क्वेश्चन के बारे में बात करेंगे. सो दिस इज डन फॉर द डे. थैंक यू. मेरे सामने ही तारता है.